So the next property that we'll be coming to is the assumption of transitivity. Now, when we are talking about the property of transitivity, we essentially mean that preference must be transitive. So that means, let's say we consider three preferences. So the assumption of transitivity is connected to the assumption of consistency. This assumption of transitivity follows from the assumption of consistency. So the fact that a consumer is transitive in his preferences and consistent in his or her preferences, you can essentially connect these two. So let's say the consumer is given three choices, A, B, C. So let's say the consumer has X1 or XA and YA, combination of good X and Y in one bundle A. And in a separate bundle B, the consumer is given a choice of XB units of good X and YB units of good Y. And in a combination or in bundle C, he is given a choice of XC amount of good X and the YC amount of good Y. So that's how, let's say, the consumer is given a choice between commodity bundle A, commodity bundle B, and commodity bundle C. Now what I do is, on the first day, I give the consumer a choice between commodity bundle A and commodity bundle B. I do not show him or her, again, not to be gender biased, I do not show that person the alternative choice of choice C. So I just show that person the choice A and the choice B. And what I see is the consumer prefers A over B. So what I realize is the consumer assumes that A will give that person more amount of utility than B. So that is why the consumer chooses A over B. Next day, what I do is, this time, like the last time I didn't show that person the choice C, today I do not show the person choice A. So I give that person an alternative between commodity bundle B and commodity bundle C. And what I observe is, this time the consumer does not have the alternative A. So this time the consumer prefers B over C. So what essentially that means is, B gives that person higher amount of utility as compared to C. So when I'm talking about the previous day, I get the information that utility derived from commodity bundle A is higher than the utility derived from commodity bundle B. But from the next day, I see that the utility derived from commodity bundle B again is higher than that of C. So essentially, the utility derived from A is higher than the utility derived from B is higher than the utility derived from C. So it's, let's say the utility derived from commodity bundle A is 5 units. I am here assuming the cardinal property of utility, because this entire approach is the ordinal approach to utility, which assumes that utility cannot be measured in numbers. But here, just for explaining this particular case, I'm assuming that utility can be measured in cardinal numbers. That is, it can be measured in 1, 2, 3 units. So let's say that the consumer achieves a utility of 5 units from commodity bundle A, which is more than the utility derived from commodity bundle B, which is, let's say, 3 units. So A gives higher utility than B because 5 is greater than 3. Next day, the utility derived from B, which is 3 units, is more than the utility derived from commodity bundle C, which, let's say, is 1 unit. So A is better than C, B is better than C, because 5 is more than 3 is more than 1. So if I compare 5 and 1, that is, if I compare commodity bundle A and commodity bundle C, I'll get the utility derived from commodity bundle A as 5 units, and I'll get the utility derived from commodity bundle C as 1 unit. So what do you think is more, 5 units or 1 unit? Of course, it's 5 units. Doesn't that mean that if I give the consumer a choice between commodity bundle A and commodity bundle C, the consumer will choose A over C because A gives him more utility as compared to C? You see, A gives me more satisfaction than B, and B gives me more satisfaction than C. So B is better than C, and A is even better than B. So obviously A will be better than C. This is what I mean by the assumption of transitivity. So this assumption of consistency and this assumption of consistency and the assumption of transitivity are very interlinked with each other. And they both together express the fact that a consumer is rational in his or her behavior. So the final assumption that we'll be talking about is the assumption of marginal rate of substitution. As I've mentioned before, the marginal rate of substitution is defined as the slope of the indifference curve. So as I've written here, the slope of the indifference curve, here indifference curve is denoted by IC, is the definition itself of the marginal rate of substitution, which I have written here as MRS. And if you know about calculus, you will know that the slope of any curve can be denoted by dy dx. So it's basically what I'm doing is I am expressing y as a function of x. Here, this dy dx does not essentially relate to economics as such, or what you can do is it's kind of the rate at which you can exchange one good with the other. That's probably the economic interpretation of this. So what you do is essentially in terms of mathematics, you express the y, the ordinate, as a function of x, the abscissa, and you differentiate it with respect to x. So that's what gives you the slope of a function. So that's a mathematical approach to the concept. But essentially, the slope of indifference curve is called the marginal rate of substitution. Now, one more thing is, as I have used this diagram before, you might have noticed that all the times, at least in our cases, that is when goods are good, that is the commodities are good and not bad. We'll talk about them in our future videos. There are essentially goods which do not have a downward sloping indifference curve. But in general, when we are talking about good goods or good commodities, the indifference curves are downward sloping. Why, you say? Because when I'm talking about indifference curve, I'm essentially talking about the locus of points which gives me the same amount of satisfaction. So let's say I have this amount of good x and this amount of good, I have this amount of good y and this amount of good x, and this gives me a particular amount of utility. If I am to get the same amount of utility from a different combination of good and x and y, the only thing that I can do is either increase the amount of good y and decrease the amount of good x, or decrease the amount of good y and increase the amount of good x. So that's the only way that I can get an equal amount of utility. And that is what I essentially mean by indifference curve. Indifference curves are the slopes, or not slope, the indifference curves are the locus of the point which I'm essentially indifferent between. That's where the word indifference curve comes from. So indifference curve being downward sloping essentially means that the marginal rate of substitution is negative. Why? Because when we are talking about negatively sloped lines, that is lines which have a downward slope, their slopes are said to be negative. And that is why MRS is essentially the slope. So if I'm saying downward sloping, it means the slope is negative. And slope being negative implies that MRS is also negative. So for most situations, at least in our cases, the good commodities will have downward sloping indifference curve. Please note, when we are talking about good commodities, I mean that both the goods on both the axes need to be good commodities. So they need to be the usual ordinary goods that we have. We will come across goods such as pollution, we will come across goods such as taxes, which are essentially not preferred by individuals or consumers in general. So we will be talking about the indifference curves, the shape of the indifference curves that they have, and they'll not essentially be downward sloping as such. So we'll be talking about those in our future videos, but for the time being, assuming the goods are normal and the fact that usually consumers prefer these goods, at least more of these goods, as per the axiom of non-satiety, we will assume that these indifference curves are downward sloping, and in other words, we will assume that the marginal rate of substitution is negative.